how to do proof by induction on whatever channel this is. It's probably going to be my revision channel or something, but please like and sub. So proof by induction on how to prove something is divisible by something. So say we have this, yes, so we have this and we have to prove that it is divisible by 5, so 5 of some number. So first of all, prove for 1. So when n is 1, that would be 2 to the 2 times 1 is 2, minus 1 is 1, and then plus 3 times 2 to the 1 is 2, minus 1 is 1, equals 5. So yeah, that's true. So now n equals k, so we're assuming that because we're going to use it later on. So that's 2 to the 2k minus 1 plus 3 to the 2k minus 1 is some multiple of 5, so 5m. Now prove for n equals k plus 1. So what we're going to do here is, first of all, substitute in n equals k plus 1 into the original. So that is 2 to the 2k plus 1 plus 3 to the 2k plus 1. And we're going to take away this. That's why we've done this already. 2 to the 2k minus 1 minus 3 to the 2k minus 1. But we're going to imagine that that's in brackets. So then you have to make these equal, so you can actually take away. So because these are already minuses, you should probably take away these. So theoretically what you'd do is you would do, well, 2 to the 1 is 2. To the minus 1, to get to that, you'd have to take out 0, you'd have to take out 2. So that would be 4 times 2 to the 2k minus 1. But you've just taken out 2 of these, because 1 minus 2 is minus 1. And then plus, do the same thing here, so you take out 2. So 3 to 2 is 9. 9 times 3 to 2k minus 1. Then you keep these the same because now they're the same here and here. So that's 2 to the 2k minus 1 minus 3 to the 2k minus 1. Then subtract. 4 of these minus 1 of these is 3 of those. You could write it in brackets to make it easier for yourself. 9 of these minus 1 of these is 8. So now you have this, and this doesn't really look like it's a factor of 5. What you can do is you can look back to the original, which is 2 to the 2n minus 1 plus 3 to the 2n minus 1. This can be taken out of this. Because what you can do is you can take out 3 of these, but this is the lowest one. So 3 of f of x, which is this part and this part, obviously. So 3 of that. And then what you're left with is 5 of these. So plus 5 of 3 to the 2k minus 1. What you're left with. So now, finally, what you have to do is f of x plus 5, 3 to 2x minus 1. And then you took away an f of x at the start, so you have to add that back on, plus f of x. So that would be 3 f of x and 1 f of x, so that would be 4 f of x, plus 5 of these. So what we're proving is that it's a multiple of 5 equals 5 something. So at the start, obviously, we proved that f of x is a multiple of 5 because of the 1 stuff. So we know f of x is a multiple of 5. And there's 4 of those. So 4 of a multiple of 5 is still a multiple of 5. Then because there's a 5 here, that means this is also a multiple of 5. Therefore, via proof that n equals 1 is a multiple of 5, we can assume n equals k and have proved n equals k plus 1 to be a multiple of 5. Therefore, can assume true for all real numbers. This, by the way, means therefore. Cool. So that's how you do it. Now there's going to be one which we're going to do like practice wise. This is going to be probably a bit harder, but we'll see. So first of all, just try it out for yourself and see what happens, and then we will go through the answer. Plus 5 times 9 to the n is some multiple of 7. So 3, 2, 1. So first of all, prove for 1. So prove for n equals 1, and then assume n equals k. And then I think that this is going to take a lot of space, so because of that I haven't written that out, but those two are the easy parts. So now solve n equals k plus 1. So that is 2 to the k plus 2 plus 5 times 9 to the k plus 1. And then that's minus, we can delete this, 2 to the k plus 1 plus 5 times, well, that should be a k. Okay, so now we've got this. You've got this part minus this part. So obviously, this is also something like, so this can be rewritten as 2 to the k plus 2 plus, then let's just take this part into brackets. 9 to the 1 is 9. 9 times 10, 45. 45, 9 to the k. Because obviously you can separate this out into 9 to the k times 9 to the 1. Then minus 2 to the k plus 1. And minus, where we're changing this plus into a minus. Then that's just 5 n to the k. So now we change this part into 2, then 2 to the k plus 1 plus 45 n to the k minus 2 to the k plus 1 minus 5 n to the k. So that is then 2 to the k plus 1, 45 minus 5 plus 40 n to the k. So now, if we look at our original, which looks like 2n plus 1 plus 5 times n to that, we can separate this part up to look like this. So we can do 2k plus 1 plus 8, 5 times 9 to the k. Perfect. So now this looks like something we can take f of x out of. So f of x is this part and one of these. So we're left with 7 of these. Plus 7, 5 times 9 to the k. And then you have to add on that other f of x that we took away at the start. So 2 f of x plus 7, 5 times 9 to the k. So therefore, we know f of x is a factor of 7, and that's because right at the start you did the because n equals 1 is factor. Then what you can do is you can show that 2 of those will still be a factor of 7, and finally 7 to the 5k 9k is a factor of 7, therefore proved for n equals 1 and n equals k plus 1, assumed for k equals n, therefore must be true for all values all real values basically. That's about it.